Hello, math fans. I'm an instructor from the University of Washington. I have a student asking me, we're at the end, 2 days before the final in my Calculus 2 course. I have 450 students getting ready for a test, and a student is saying, I don't remember how to compute inverse trig values. And I try to make the case that everything you'd ever want to know is in the unit circle, but I thought based off of this question, I'm going to say a bit more, give some gimmicks. All the values are there. The truth is, you really want to memorize this unit circle somewhere in your formative years and know these first few values, because everything you'd ever want is in there. And the key idea is that the x-coordinate is the cosine of that angle and the y-coordinate is the sine of that angle. And if you go beyond 90 degrees, it kind of doesn't make quite the same sense as a right triangle, but we define it to be what the value will be in those other coordinates. So for example, if you want cosine of 3 pi, let's do 2 pi over 3. You go to 2 pi over 3 and you get the x-coordinate, it's negative a half, blah, blah, blah. Hang with me for a second. I hope it'll get more fun in a second. If you want something like secant, let's say secant of 2 pi over 3, you do have to remember that secant is 1 over cosine, but then it's in the unit circle and you get the answer is negative 2. If you want something like tangent of pi over 3, you do sine over cosine, but the sine is the square root of 3 over 2 over 1/2, so you get square root of 3. Okay, that's not what I wanted to talk about here, but really the answer to almost any trig question is to have the unit circle with you. It's often faster than looking it up online or computing it in a calculator or trying to remember what it is. Just have this in front of you. In our classes, we allow a note sheet, so I would just put that on your note sheet in your definitions. But first, years ago, I'm sure someone else told me this or I observed it, but if you can just remember one thing, which is that sine of 0 is 0, then you can remember these values, these main values that I have listed here. So I feel like most calculus students can remember this, that sine of 0 is 0. And if you can remember that, usually you can remember that cosine of 0 is 1. So let's say you only have room in your brain for remembering one specific fact about trig. I think most students have this in their brain already. If that's not in your brain, then this may be less helpful. But let's assume that sine of 0 is in your brain. Okay, so now we're going to put the first few angles. 0, 30 degrees, 45 degrees, 60 degrees, 90 degrees, and this is pi over 6, and this is pi over... And what I'm about to do is not original in any way. People do this in all sorts of things, but there's a goofy way to remember this. Like I said, if you're unwilling to commit any of the rest of the stuff to memory, is you put a 0 here, and then you put a 1, 2, 3, 4, and then you reverse. 0, 1, 2, 3, 4. I'm sure someone that I know is going to see this that knows math and be like, I can't believe you said this and made this video. It's people like you that are the problem. So take the square root of everything. Square root, 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 divide by 2. And there's your answers. There's all the starting values in the first quadrant, the standard starting values. This gives you just 0. This gives you 1/2. This gives you root 2 over 2. This gives you root 3 over 2. This gives you 1. This gives you 1. This gives you root 3 over 2. This is root 2 over 2. This is 1/2. This is 0. I tell students the way I actually remembered this when I was a student is, to me, the only things I would sometimes confuse, which makes sense because they're so close, is these two. And I just remember on this point, the y-coordinate is bigger because visually I can see that the y-coordinate is bigger. And so the y-coordinate had to be square root of 3 over 2. That's how I always can remember that sine is square root of 3 over 2. But that's kind of specific. The other thing you can always do, before I go a little further, is you can draw an equilateral triangle. And the reason that's helpful is because this is 60 degrees, this is 60 degrees. And if you make this, if you're trying to make a 2, 1, I would make this side 2, make this 1, make this 1. Now it's equilateral, and you have a 60, 30 triangle. And so, for example, you can immediately see that cosine of 60 degrees has to be a half. So you can draw an equilateral triangle to get this same thing right here. Okay, now let's go a little further. The person who asked this question was actually asking about inverses. And there's plenty of things we could say about inverses, but let's just talk about in this first range. So if somebody asked you what the inverse sine of square root of 3 over 2 is, it's still the same table. You just are going in reverse. It's when is the y-coordinate, so this is going to be pi over 3. And for this video, I'm not going to worry about principal domain. There are things to talk about there, but I'd like to keep things simple. So let's just talk about this domain. Okay, if you go beyond that, we do need to talk about how sine is restricted to this domain, negative pi over 2 to pi over 2, and cosine is restricted to 0 to pi, because otherwise there's infinite number. There could be multiple answers. Let's just talk about in this domain where we don't have to worry about that issue. Okay, so that's it. If you need inverse cosine of root 2 over 2, you're just looking for that value. So to me, remembering these values this way is no harder than remembering this direction. It's just instead of going this way in the table, you're going the other way. Okay, that's how inverses are. But something about an inverse trig just draws in some questions. So I think what the person was asking was about inverse trig of other values. Okay, so something like an inverse tangent. So you could, honestly, if somebody asked me for inverse tangent of root 3, what I would be doing is I would be looking for when sine over cosine. So I think of tangent as sine over cosine. When is sine over cosine? And maybe it helps if you have trouble with this, is just say a blah. And then say square root of 3 is tangent of blah. And then say, when would sine over cosine be square root of 3? In other words, when would sine over cosine? If it helps you, maybe you want to extend this table. Tangent is sine over cosine, so it's going to be 0. It's going to be 1/2 over square root of 3, and if it's 1/2 over square root of 3 over 2, it's just 1 over square root of 3. Now, part of the confusion is this can also be written as square root of 3 over 3 if you rationalize. And I think that's sometimes where people go awry. It happens in this table as well. 1 over the square root of 2 is the same as square root of 2 over 2. So sometimes that confuses people. Like if this had said, what is arc cosine of 1 over square root of 2? That might have confused somebody because they wouldn't have seen it in their table. So that is a separate challenge. But this is 1. This is square root of 3. This one, and this is undefined, does not exist. So you could extend your table, but if you think about just the division, I know that it's this one because it's sine over cosine. And so that's how I know quickly that this is pi over 3. I'm still using the unit circle. Oh, I switched colors because of that. Okay, so I think the question... So that's what I do is I basically translate everything to sines and cosines, and then I look here whether it's inverses or not. So when I'm trying to do something like arctangent of 1, I ask myself, when are sine and cosine the same? So this is pi over 4. So that's how I think about it. So you could always translate. So let's say you had a question of sec, and maybe I'll come up with better ideas. I'm making this video quickly, but I'm not as good about knowing these values, so maybe I should create them right now so that I can get better at this. Secant of this. Secant is 1 over cosine. And so this is 1. This is 2 over root 3. This is 2 over root 2. This is 2. And this is undefined. So if you're worried about your speed with these, you could generate these a few times, but I usually do it on the fly. So if somebody gives me square root of 2, I'm basically saying which of these is the square root of 2. And you say, well, none of them are. I think you just gave me something that doesn't work. Well, if you multiply top and bottom by square root of 2 here, you actually get square root of 2. If you multiply top and bottom by square root of 3 here, you get 2 root 3 over 3. So this has to be pi over 3. Do. But honestly, you could do this another way. So this sort of brings me to a few thoughts as I just say this now. So when it comes to tangent, I would just look in the unit circle and divide. Sine over cosine. When it comes to secant, there is a general approach. If you have inverse secant of, stuff equals blah, then you can write stuff, these are very mathematical terms, equals secant of blah. Okay? And you can rewrite it another way. And that other way is that cosine of blah is 1 over stuff. And so the truth is that inverse secant of anything, let's call it A, is the same as inverse cosine of 1 over A. And similar, inverse cosecant of A is inverse sine of 1 over A. Now, those are not things I use very often, so I kind of had to think about that for a second. But the point is, if you wanted to know what inverse secant of square root of 2 is, it's the same as asking 1 over square root of 2 for cosine. So we're just basically translating everything back to sine and cosine in all situations. With secant and cosecant, you can translate directly back. So let's try yet another one. What is cosecant of, what would I give you? 2 over root 3. So you'd be asking yourself, there's two ways to think about it. You could say inverse sine of root 3 over 2. Or you could take a second and say, when is sine of theta 1 over 2 root 3? There's another way to say this. Okay, I can't think of any other ways to say this. But basically you're looking for when sine is this, so it's pi over 3. All right, I think I'll stop there. That just gives you some things to think about. Maybe in the future I'll have better ideas and make a cleaner video. I just was trying to answer the student question right now. Hopefully you kind of appreciated some of those things. But in my mind, everything is in this table. When someone asks me what inverse cosine of a half is, I look for a half right here. When somebody asks me what inverse sine of 1 is, I look for a 1 in the y-coordinate. So those are in the unit circle. When somebody asks me inverse tangent of 1, I think about when sine and cosine are the same. Okay, hope that helps a little bit. The big message is have the unit circle out. Even if you don't have it memorized, when you do calculus, you should have it out. It will make you faster and it will give you exact answers. And eventually, if you keep using it, you'll be able to recall some of those things. And if you're working with trig at all, you will want to be able to recall those things.